Okay, we're back. Hopefully you did well on lesson 12-3, side angle side, proving that two triangles are congruent by that. We're gonna jump ahead to lesson 12-4. Before we jump into that, I wanna review with you just quickly how to tell if two triangles are congruent. Two triangles will be congruent if all of their parts are congruent and corresponding. So all their three sides match up and all their three angles match up. And then we learned that we can do a shortcut, side angle side, as long as two sides of one triangle match up to two sides of another triangle and the included angle is congruent to both, then it works. And the two triangles will be congruent. And that'll lead us into today's lesson. But before we do today's lesson of equilateral triangles and isosceles triangles, those are special, we're gonna review real quick how to find the missing angle inside of a triangle. Remember, all three angles of any triangle, doesn't matter what the triangle is, as long as it's a triangle, and all three angles add up to 180. Not their sides, just their angles. So we would set this up as x plus 56 plus 35 equals 180. Now the gist of this is, we'll add these two together, so x plus, and that'll be 91 equals 180. And then we'll subtract the 91 from 180. Now x equals 89. Now that's the gist of it. Basically all we're doing is you take those two away from 180 and you're gonna find it. Okay? So I'm gonna do that pretty quick on these other ones just to make sure that we review it with you and you can get it. So we take 180 and we subtract off 25 and we subtract off 72 and we get 83. Okay, we take 180, we subtract off 112, and we subtract off 47. That's x equals 21. And you can double check this by adding the three angles back together, and you better get what? Yeah, that's right, 180. But we better write that down correctly, 21. And then our last one, 180 minus 49 minus 51, and we get 80. Okay, any questions on that? Remember, I do prefer that you set it up in an equation because it helps you so much in your progression towards, knowing your algebra, knowing how to set up two things equal to each other. Once you know two things are equal, you can set them equal to each other. Or once you know they're the same, you can set them equal. So that's why we know those three things add up to 180. That's why we set them equal to each other. Okay? All right, that's going to bring us to our lesson. We're going to talk about isosceles triangles first. In these isosceles triangles, the base angles are going to be congruent. So watch. If two sides of a triangle are congruent, so two sides of a triangle are congruent, then the base angles are congruent. The angles opposite those sides are congruent. So we would be able to put a mark here and a mark there. We can do that once you see those marks on the sides. So we would say the measure, or well, we don't even say measure, we just say angle B is congruent to angle C. And that's what we can come up with after we know that the two sides are congruent. One other thing I want to make sure and point out is, where is the vertex on this triangle? Now, every triangle has three vertexes, but an isosceles triangle is unique. It has one vertex that we specify as the vertex. It is always where the two sides meet. It's always where the two sides meet. Because then we know that angle is not one of the base angles. And we call these down here the base angles. I guess I better draw that just a little bit better. This angle and this angle are the base angles. Okay? And that's what we specify as that, because the base angles will be the same, but the vertex angle won't be. Okay? So what's cool about this? You only need to know one angle on this triangle and you can find all three. Because if you know this one, well, then you know that one. If you know two of them, you can find the third. If you know this one, you can subtract this one, the vertex angle, from 180, and then whatever's left, just cut it in half and you'll have the other two. That's what's pretty cool about these triangles. You don't have to know more than one angle. However, on our last problems, we had to know two angles to be able to find the third. But on this type of triangle, we only need to know one angle and we can find the three. Okay? Well, here's the converse to this problem. The converse to this is, if I have two base angles that are the same, well, here's what's cool. I have two sides now that are the same. Again, there's the vertex, because it's where the two sides go that are congruent, and then the base angles are already marked. So one way or the other, if you see the markings on the picture, you can throw the other markings on there when you need to. Here's what I mean. Let's say I have a triangle and it looks like this. And on that picture, I have that and that marked. Well, then you know right now that this triangle is isosceles. And this angle would match this angle. Now, I made two marks on this one this time because I wanted to show you that it doesn't matter. They just have to be the same markings. Okay? Well, where's the vertex on this thing? Let's A, B, C, if we were called that. Then this right here would be our vertex. These two would be our base angles. Right here and right there. Any questions on that? Okay, likewise, if I had a triangle that looked like this, and it was F, G, R, and we had this angle marked and this angle marked. Let's just say those two angles were already marked. They were congruent. Well, then we know right off the bat that this side and this side would have to be congruent. Therefore, this would be the vertex, and these would be our base angles. Okay, everybody? All right, that's where we're headed. Just remember, anything that's congruent is the same. When things are the same, you can set them equal to each other. Okay? That'll help us learn some of the things and solve some of the things we're going to be doing. All right? All right, so let's name this stuff on this picture. If I have triangle DEF and DE is congruent to DF, DE is congruent to DF, name two congruent angles. Well, what angles would be congruent? It would be angle F and angle E. So angle F would be congruent to angle E. And that is the terminology that they would want to see when you write it up. All right? All right. If F segment, and remember, it's important that you learn how to read this geometry terminology, the geometry terminology this way, because it's speaking a new language. So when we see this symbol, it's segment. So HG, segment HG, is congruent to segment HK. So let's mark those. HG is congruent to HK. And I could have put as many markings as I want, but they both would have had to have the same markings. Then what angles will be congruent? Well, our angles that would be congruent would be angle G and angle K. That makes this H for this triangle the vertex. But you got to remember, it's only that part of it. Okay? And so we would put it up here. G and K. Excellent. Okay, so now let's read the rest of it. It says, if angle KHJ, now you got to remember, 3 letters means you got to follow the letters, and the center letter is where the angle is. Okay? That's where the vertex is for that picture that they're trying to tell you to mark. So KHJ, and I'm going to put 2 marks on it because I'm showing you that it is different than these angles down below. It's different than that angle. Okay, it's congruent to KJH. KJH, so it would be down here. And those 2 angles are the same. Well, if those 2 angles are the same, what 2 sides will be the same then? Well, let's take a look. Well, it's the sides opposite those angles, so it's simple. It's the same as this one, and that one already has 1 mark, so I'm going to have 1 on that one. So we would say KH, and we would say KJ. And again, it's really easy to see where the vertex is for that picture, because now this one would be the vertex, but it would only be for this part of the angle. Does that make sense? Because that triangle has that vertex, this triangle has this vertex. They are both isosceles. Now some of you might be wondering, well, how can the sides be the exact same markings, but the angles are different markings? Let me help you with something. Angles are their own thing. Angles stay with angles, sides stay with sides. And so sides can be the same length. And I'm just showing you that this side, and this side are all three the same length. So if this was 7, that would be 7, that would be 7. If this angle was 50, that one would be 50. If this angle was 30, that one would be 30. You just have to remember, angles are their own thing, sides are their own thing. Whatever is the same though, you can set equal to itself or to that other item. All right? All right. Let's jump ahead to another sweet triangle. This one is equilateral. Equilateral triangles are also known as equal angular triangles. You'll understand that because, look, the angles are all marked the same. Well, so are the sides. Remember, sides don't have anything to do with angles other than you can tell if 3 sides are the same, then the 3 angles better be the same. You do not need to know any angles on this picture. You can find them all because how much do the angles add up to? 180. If they're all the same, it's 180 divided by 3. Well, 180 divided by 3, because this is like x, x, and x, and that's 3 of them. So the problem itself is 3x equals 180. And we're dividing by 3, and that is 60. So every angle on this picture is 60 degrees, and that's the way it will always be on every single equilateral triangle. Every one of them always have 60. Okay? Now the sides themselves can be whatever they want. Just because these angles are 60 does not mean the sides are 60. Okay? The sides, well, let's say this was 10. Well, then that one's 10, that one's 10. Let's say this one's 5, then this one's 5, that one's 5. Let's say this one's 4, then this one's 4, and that one's 4. Get the idea? Okay? All right, well, the converse is if all of the angles of one triangle are the exact same, then the converse is all of the sides are the exact same, okay? So when you have all 3 angles the same, you have all 3 sides the same. So I'm going to try to show you and illustrate that real quick. Let's say I have a triangle and I show you that. If that's the case, you know it's equal angular. Well, then you know it's equilateral. Got it? And one more. Let's say I have a triangle and I have all those sides marked. Well, then I know it's equilateral. So I know it's equal angular. By the way, what are the angles? That's right, 60. Each angle would be 60 degrees. So 60 here, and 60 here. Total, 180. Does that make sense? Any questions? All right, we'll move on. All right, let's do this problem right here. All right, find the measures of each of the angles. Oh, we just did that. So this one would be x, 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 because we don't know what they are. So then we would say x plus x plus x equals 180. That's 3x equals 180. I'm showing you the long way. And it's 60, just like we said it was. But you already knew that from the previous chart. Okay, so each angle is 60 degrees. Pretty cool, huh? All right, we're ready to move on. All right, so find the lengths of S to T on the triangle at the left. Well, the triangle at the left, what kind of a triangle is it? So make sure you always identify what kind of a triangle it is. It is equal angular. If it's equal angular, then it's equilateral. So S to T is 5. So ST equals 5. Some of you might be wondering, why didn't I put the little line above it? Because as soon as you go to numbers, You don't need the symbol for the segment anymore because now we know that equals 5. Any questions on that? By the way, what would the perimeter on this triangle be? Well, can we find it out? You bet. This would be 5. The perimeter would be then 15. Any questions? All right, let's move on. Find the values of x and y in the diagram. All right, we'll identify where your triangles are, what kinds you have. In our picture, we have 2 different triangles. We actually have 3. I hope you can see 3 triangles. But we're going to specifically work on the 2. This triangle up here is equiangular, which makes it, you said it, equilateral. This one down here is what? That's right, isosceles. And so we know it's isosceles because the 2 angles are the same, so the 2 sides are going to be the same that are opposite from those. And so now we know that we can set up a couple of equations to solve for our problem. Well, y will equal 4. There's that one. And then we can set 4 equal to this to get it. So x plus 1 equals 4. Subtract the 1. And x equals 3. So x equals 3, y equals 4, based on the knowledge we've just learned about isosceles triangles and equilateral triangles. All right. Moves on to this next problem, and we are going to discuss how to find out the information they're looking for. It says in this lifeguard tower, PS is congruent to QR. So I'm going to mark it. PS is congruent to SR. Okay? PS is congruent to QR. And angle QPS is congruent to angle PQR. So those are the ones up here. So it is QPS. That's this one. And I'm going to mark it like that. I know it looks like it's 90, but they didn't say it was 90, so I'm not going to mark it like 90. Then they said angle PQR. So PQR, that's this one. They said those were the same. Okay. Now, they're asking us to explain how to prove that this triangle, and it's kind of hard to see because they're overlapping each other. So look, follow the letters, QPS, QPS. So it's this triangle right here, this one, and it's this triangle, PQR. So it's this one. So it's this triangle that needs to be pulled apart like this. So I'm going to redraw it and you see what I'm going to do. Now, when I redraw it, I want to show you something that you're going to need to look at, and it's called reflexive. We talked about it last lesson. So watch. So I'm going to draw the first one they said. That is P, Q, and S. And now I'm going to mark what's in green. This is marked, and that's marked. Everybody with me? Now I'm going to pull this second triangle off to the side. It's this one. I'm going to pull it off to the side so I can look at it. I'm going to label it P, Q, R. Now watch, I'm going to mark what's in green, that and this. Now, talk to me about what you see that's reflexive on the picture. The thing that's reflexive that pulled apart that was the exact same for both pictures is this side right here. 1, 2, and 1, 2. Now we're looking at 2 triangles that have the exact same markings, and they are side, angle, side, side, angle, side. And so yes, they are congruent. And I'm just going to use the symbol. They're congruent by side, angle, side. And that's enough because our picture shows it. Okay? Explain why triangle PQT is isosceles. Okay, well, if I pulled these 2 pictures apart, and this angle matches that angle right now, what we can do is continue to say in terminology, well, if that's true, then this angle right here, I'm going to put 2 marks on it, and 2 marks on this one in blue. Well, if those 2 marks are already marked, then boom, boom, those 2 sides would have to be marked, and I'm going to do 2 marks on them because we already have 1 for the green. And therefore, because of the angles theorem, the converse theorem of the angles being congruent, the sides are congruent, and that's why it's isosceles. Okay? And we're to our last picture. All right, it says find X and Y on the diagram. We have three different shapes on this thing, but the two we're gonna focus on are our two triangles. This one up here, which is isosceles, and this one over here, which is equilateral, okay? So, I'm gonna separate them. Marked, and we wanna find our Y. I'm also going to mark that, and I'm gonna mark that. Does everybody understand why? I can mark those because this side, and this side were congruent, so this angle and this angle are congruent. Now I'm gonna draw the other triangle off to the side. I'm gonna go 1, 2, 1, 2, 1, 2, which tells me it's equilateral. And I could even put the 2 marks there, not that I need to, but that's that side that's reflexive between the two. This side was the exact same as that side. We didn't really need that. They asked for us to find that angle right there. Well, the moment we know that, well, we know this. And all those are the same, so X has to be how much? That's right, 60, because it's 180 divided by 3. And on this one, we're going to be able to figure that out based on this being 60. So watch, if this is 60 down here, I'll use it in a different color. If this is 60 right here, and that's 90, well then this has to be 30. So if that's 30, then this one's 30. And now, like I said, once you know one angle on an isosceles triangle, you know all three because you know this one, we already knew that one. Now we can go find our Y value by taking 180 and subtracting 60, 30 apiece. So Y plus 30 equals 180. That's Y plus 60 equals 180. We're going to subtract the 60, and Y will be 120. So that is actually an obtuse isosceles triangle. And yes, you can have an obtuse isosceles triangle, you can have a right isosceles triangle, and you can have an acute isosceles triangle. You can have all three. Okay, I hope that helps you. Good luck with your lesson, and we'll see you next time.